Hello, welcome everyone. I just want to welcome you here. I'm Art Baudo. I'm a principal specialist in the ECT core group at AWS. Joining me today is Chris Foote, who's a senior go-to-market specialist in the compute team here at AWS. I'd like to thank all of you for coming to CMP 221, selecting and optimizing EC2 instances. Today, Chris and I are hoping to give you an overview of compute options on EC2. Talk about some of our compute offerings, offer you recommendations, and walk you through instance selection. Today promises to be a fun session where I hope you learn a bit about our EC2 instances, how to maximize your compute workloads, and also how to get started doing all of this stuff. So thanks for joining Chris and I today. Let's get started. Here's an outline of my agenda. I plan to cover an overview of the EC2 instance options, how you can understand the offerings that we have, and I'll try to give you a little bit of guidance on the instances and talk about the performance that we offer. I'll also try to help decode the differences between instances, and I'll walk a little bit through some of the most common names of our instance types, giving you an idea of how you can make a selection yourself. I'll also walk you through how to choose the right instances for you. And I'll talk about some of our most common workloads, giving you an idea of how to select instances based upon those workloads. And I'll give you some tips that I've learned along the way myself for instance selection and the process to guide you along that path. Chris will then come up and talk to you a little bit about our EC2 instance selection tools to make the selection process even easier for you, and tools that can make your own choices. And I'll give you some details on that selection and some other alternatives as well, and a quick demo that we'll do on our slides here. And then we'll talk briefly, concluding with a little bit about pricing, how you can look and think about capacity and managing capacity within your portfolio here, and also a brief discussion about our performance. So, sound like a plan? So, 15 years ago, this past August, EC2 was launched. We started offering in the cloud with a basic instance, our general purpose compute instance. It's also known as our M family of instances. It's still one of the most popular instances that we have, but since our launch 15 years ago, we've made some significant advances. And many of those advances are based upon hearing from customers such as yourselves. Customers are the backbone of AWS and what we do, and it's customer needs that have actually driven our instance additions and managed services to our offerings. So our goal is to make the cloud even more accessible for all of you here and make it simple, or as simple as possible, to use. So let's fast forward to today. AWS offers you a choice of how you consume compute. Whether you choose to use existing applications or build new applications in the way that suits your business needs, we offer instances, containers, or serverless compute. And with each of those areas, we're rapidly adding new compute capabilities and improving our existing offerings. If you look at some of our recent upgrades, you'll see that we've increased the total amount of memory available per vCPUs, responding to the fact that customers have asked us and asked me for a lot more memory as they do compute. In addition, we've continued to offer the latest technology and performance, and are all the while trying to provide the best price to performance ratio, which is what we see as the most important thing to you, getting you the best price per performance. So how do customers make decisions about where to get started with EC2? Many customers arrive here at AWS looking to start using instances, which is the traditional way to run compute when you want direct access yourselves to all of the resources. So using specific instances, such as our C, M, or R family, allows you control over that resource. And you can design your workload to match certain aspects of that instance type. However, this may not be the most efficient way to do it for each of you. Some people would prefer to use something else, such as containers. Containers allow customers such as yourselves to deploy in smaller chunks in the cloud and compute, and it's easier to iterate on and move around. And it also increases the level of flexibility that we offer you. It takes away a level of traditional work and makes it easier for you to manage it. The final way is if you're not even concerned about the server, you don't want to have anything to do with the server, you can use some of the managed services or our serverless compute, such as Lambda that I have up here on the slide. Not moving forward. Okay. We will get to the next slide, I promise you. Oh, here we go. All right. All right, I spoke briefly about the usages of AWS instances on the prior slide, but I'd like to give you an overview of the entire offering that we have. So today, I think you've probably heard this in a couple of the keynotes that have been out there. AWS offers the largest, the broadest, and deepest compute platform with nearly 500 instances. I believe Dave Brown actually specifically called it out as 485 instances that are here, and we continue to add more. If you come back to reInvent next year, I'm sure the number will easily be over that 500 mark. Over the last 15 years, AWS has invested in new capabilities, such as faster processors. We've introduced new instance families, such as accelerated compute. Those are our GPUs and Inferentia, and enhanced our networking, storage, and management to remove performance bottlenecks. We've also introduced options such as our Elastic Block Store to improve greater performance and offer storage flexibility with the instance storage. Elastic Inference to reduce the costs of running deep learning inference by up to 75%. And Elastic Fabric Adapter, EFA, as a network interface for any supported EC2 instance to run applications requiring high levels of internode communications on scale at AWS. We offer instances of a variety of categories, capabilities, and options within each. And you can use a general purpose compute, let's say an M6i, which is on an Intel processor, with a specific amount of memory, so from the category here. And you can use that with EFA if you'd like. So what I do when I'm looking at these is we have the plus sign here. You can start combining here. You start choosing from your categories that general purpose instance, add the capabilities and the options. And I'll explain a little bit more how you go through this as we go forward. So let's deep dive a little bit into that portfolio. Today, our EC2 instances are powered by a range of processors from Intel, AMD, as well as our own Graviton 2 processors. Graviton 2 processors are custom built by AWS using a 64-bit ARM Neoverse core, and they deliver the best price for performance on your workloads at EC2. I don't want to forget, if anybody have attended Adam's keynote or Dave's, we pre-announced Graviton 3 as well, which is also built off of that Neoverse as well. So it's continuing our update here as well into the ARM-based architecture. So Intel has been with us from the very beginning of EC2. As a matter of fact, they were the first instance that was launched in the M series. And today, frankly, the majority of our instances continue to be powered by those very latest Intel processors. This summer, we started our upgrades to the Ice Lake family, which is the 6th generation of those processors. And these are not simply off-the-shelf Intel Skylake, Cascade Lake, or Ice Lake processors, but we've partnered with Intel to bring these processors that provide that highest sustained all-core turbo frequency, allowing you to run your workloads faster. Just this year, as I mentioned, we updated our Intel Ice Lake to our Intel Ice Lake platform. We have launched so far the M6i, C6i, and R6i instances that reflect that upgrade. We also believe in a diverse portfolio as well here at AWS. Included in that is AWS launched our first AMD instances, which were also in the x86 architecture family back in 2018. Those are powered by AMD's EPYC architecture, and they offer you, our customers, a 10% price per performance discount versus comparable x86 instances. So if you're running x86 workloads, there's an option here to save some money using the AMD architecture. Today, we have multiple instances available on AMD across the majority of our regions that feature the AMD EPYC processors. And we announced in March 2021 that we would support the AMD Milan instances. And on Monday this week, we started that rollout. M6A started launching on Monday. And finally, last year, we announced the Graviton 2-based instances, and the Graviton 2 instances offer up to a 40% better price per performance compared to those 5th generation x86 instances. They're available in a variety of CPU and memory ratios, and with or without the local instance storage. Those instances power a broad spectrum of workloads, everything from application servers, video encoding, and HPC to microservices. And we have open source database and in-memory caches on those platforms. That effort continues with Graviton 3, and I'll get to that a little bit later in our conversation. But aside from just a CPU conversation here, we offer a wide range of hardware accelerators. So hardware accelerators range from our GPU instances that we offer through NVIDIA, so the latest Tensor GPUs, which we just talked about, G5, the G5 family in the last couple of weeks here. We have FPGAs from Xilinx and our own Inferentia platform. So as you can see, there's a lot to choose here based upon what your workloads are that you would like to bring here to the cloud. So before we move into my next section of the conversation, I promised a little bit of a discussion about Graviton 2. I know you didn't sign up for a Graviton class here, but let me give you a little bit of an overview because I think it's important in your instance selection process. If you've not been following our work in this space, we introduced ARM-based chips at reInvent. Our first announcement was in 2019. These chips represent a partnership between AWS and Annapurna Labs, which is a wholly owned subsidiary of AWS. Today, the Graviton instances are not only in the computer, storage, or memory-optimized instance families, but we now also offer burstable and memory types. So you can see here, M is our general-purpose workloads. The burstable ones are the T4G. And then we have our C6, which is the compute, R, our memory-optimized, and then memory-intensive. And then the X2 is the memory-optimized, the newest instances. So last year, we added the T4G, which offers you the lowest price and best performance for general-purpose workloads. And at reInvent, we again launched C6GN with 100 gigabytes per second of networking for compute-intensive workloads such as high-performance computing. And this year, we announced the introduction and addition of the GPU to the family using the Graviton CPUs with an NVIDIA-based GPU. That's that G5 that we talked about a little bit before, the G5G. Now, customers looking to adopt the Graviton 2 instances, their first concern is this is a different architecture. I've done a lot of work on x86. My entire corporation is using x86. How do I get started here? So that's what we do here. We're offering you a free trial on the T4G. The T4G instances are part of our lower-end compute instance sizes, And so you can take a look and try those out right now. And if you aren't familiar with this, we've tried to make the conversion as easy as possible. We also offer a series of white papers and docs off of our web pages to help with the conversion process if you're interested in the ARM-based architecture. A final thing here on the Graviton slide, in our first generation, you can see this is an actual picture of the Graviton 2 processor that's here. As I said before, it is the 64-bit ARM Neoverse cores, and there's roughly 30 billion transistors in that. This is our first 7-nanometer processor that was deployed at AWS. So we deployed our first 7-nanometer process technology here last year. And what does it mean? So AWS's Graviton has 7 times the performance, 4 times the number of cores available to you, and 5 times faster memory, and twice the total amount of caching in our second generation, even as our first. And this is really tremendous performance. So I'd like to take a look how we use that in our instances. I'll also mention, with the 3rd generation processor, we discussed that there's a 60% reduction in the amount of power that's utilized. So for folks that are also, at the same time, not only concerned about performance, but concerned about how much power is used to power their cloud-based instances, the Graviton instances also offer an option in the cloud for that. So with the success of our first generation and A1 instance family, we wanted to broaden the workloads that are there. So for Graviton, especially the workloads in high performance. Don't worry, we won't stare at a blank slide for that much longer. So what are those families? So web and gaming services, our open source databases, media encoding, in-memory caches, and even electronic design and automation, EDA, for those doing silicon design and testing. And we ourselves eat our own dog food. This is also utilized by us for the development of some of our silicon and processors. We've continued to innovate here, and we now have that complete portfolio, as I mentioned, the M6G, T4G, C6G, R6G, X2GD, and the G5 property. So with all of that, I've rolled out a lot of information about a bunch of instances. How the heck do you make the right decision yourself for the workload that you're using? With all those choices, I'm going to try to help demystify the instance selection process for you as we go forward here. Before we get through that, let me walk through some key concepts here so that you can understand that processor selection process. So there's something we call an Amazon machine instance. It's also known as an AMI. An AMI is a template that defines your operating environment, including the operating system, and a single AMI can be used to launch one or thousands of instances at the same time. You might have an AMI for CentOS, for example. Instances themselves provide our compute power. As I mentioned before, those are our fundamental building blocks here, and instances are created by launching an Amazon machine image, or that AMI I talked about earlier, on a particular instance type. So you launch the AMI within the C series. That's how you would get started. The instance types comprise various combinations of CPU, memory, storage, and networking capacity to give you that flexibility. And then an instance family. An instance family is a collection of those instance types that are designed to meet a common goal. To make it easier for you to select the best option for you, EC2 instances are grouped together in a family based upon the target application profiles. So let's deconstruct this example that I put on the screen here. I've seen quite a few of you take some photos of it, but let me try to walk you through it as well. So the first letter in this is the instance itself. So in this case, this is the M family, the instance family M, which is which is our general purpose compute family. The second letter here is our instance generation. In my example here, this is the 5th generation processor. So you understand that where you are in the generation selection. The next letter is the CPU. This is a slight change that we've made this year where we've tried to demystify this further. I know somebody came up to me at the booth and said, all these crazy letters you people provide, it gets me confused. I swear we're trying to actually make it simpler for everybody here with doing this. So the M, first letter again, is the family. Second, here is the generation. The third is the processor type. So in this case, I have an A. That's an AMD instance. If it was an I, it would be an Intel instance. Similarly, if you had a G, you would have Graviton. Seems simple, right? And in this example, I also included a D. I labeled it additional capabilities. But additional capabilities is in this case, add an additional NVMe in this case. So if you need the additional storage, you would look at the NVMe here. And in the end, it looks like I have a slight slide, lovely thing going on here. The name is actually extra large, X large. And each of the instances increase in size. So you could have an XL, then you have a 2XL, 4XL, 8XL, etc. Just a note about our recent updates. If you look at the M6i family, we now have a 32XL that's offered with the 6th generation family, whereas before this summer, I only had up to 24. So if you have large compute loads. And if you look at the AMD side, the M6i that has been launched, we also offer a 32 and a 48XL. So if you have really large amounts of compute, we can satisfy that as well within these instance families here. Okay? Oh. One other thing I almost forgot. We always maintain the same ratio of memory to compute within that instance family. So if you look at the M family here, in this example, we're talking about the M series on AMD, you get a ratio of memory to compute, okay? So the ratio of memory to compute here is 4:1. The ratio of memory to compute in our C instance family is 2:1. And the ratio of compute in our R instance family, the memory optimized, is 8:1. We maintain that ratio every time you increase. So if you go from XL to 2XL, you're going to have twice the amount of vCPUs as you did on the XL and twice the amount of memory. So it's a proportional increase that will happen. But we maintain, as I mentioned, the 4:1, 8:1 ratio. OK. So next. Now that we understand what an instance is, let's talk about the selection itself. And before starting on that selection, what the prerequisite for your workload is ask the following questions. What are things I need? What are my business requirements is what I think you should start with. Consistent high performance, or do I need low cost to keep up with certain SLAs that are operational for us? And what are the bottlenecks? This could be disk I/O, it could be network utilization. And if there are multiple bottlenecks, you should start listing them on a paper. What are your most important? And once you have those questions answered, you can start moving on to defining the right workload. Okay? So we understand what is the instance process here, but my message in blue is don't overthink it here once you get started. When you start with the instance selection process, you should focus on what are the key attributes that are important to your workloads as a customer here, and you use it. Once you answer that, you can move forward. So here's my first tip. You should familiarize yourself with the type of instant categories that we offer. I want to emphasize you don't have to memorize all of this here. There's no need to memorize it. We try to post all of our documentation online and try to follow that up with docs and other information as well for you to take a look at. But just to kind of quickly talk about this, we offer different types. We have the general purpose, our burstable, which is the T instance family, the compute intensive, memory intensive, high storage, high I/O, and dense storage and accelerated computing instances. Our general purposes instance provide that balance of compute, memory, and networking, and can be used for a variety of diverse workloads. Our compute-optimized instances are ideal for compute-bound applications that fit from high-performance processors. Instances belonging to that family are ideally suited for batch processing workloads, media transcoding, high-performance web servers, and high-application computing, HPC. In addition, scientific modeling and dedicated game servers and ad service engines, along with some machine learning workloads, are used in the compute-intensive area. The memory instance types are designed to deliver that fast performance for workloads. And finally, our accelerated instances use hardware accelerators or coprocessors to perform functions, such as floating point calculations, graphics processing, or data pattern matching more efficiently than is possible from running just software on a CPU. OK, so my next tip is focus on using Amazon EC2 efficiently. What does that mean? It means the thing I recommend is don't get started with EC2 with your initial selection and try to optimize on all vectors, or specifically try to focus initially on cost. We will help you get to the cost space as well. But after you've optimized on some of your key business factors, you can use some of the tools that Chris is going to talk about a little bit later in today's presentation. And before I give you an overview of that, the prerequisite is that you need to know and understand your own application and workloads. And you should ask yourself a couple of those questions I mentioned before. What are the key business requirements? Again, what are those bottlenecks? And once you have some of those questions answered, it's easy to do that. And here's that tip again. Don't try to over-optimize here. But optimize by using our tools. And you can use that optimization in our tools to learn about your own consumption pattern. The interesting thing about using some of the tools is we can help you provide recommendations once you get started. So if you have optimized in using M5 4XL, for example, we can even show you that maybe you should be trying out 2XL or XL or something like that. So once you get started and recognize what family, what your bottlenecks are, we can also use some of our tools to help you move forward. Every one of you, whatever company you're working for, knows your application better. Most certainly you know it better than I do. Okay? So as that customer, you know those key characteristics, and you know what's important, and that means you are going to play the key role in identifying and optimizing the actual selection process. And so by giving you this overview of these selections and the prerequisites, we need you to also know what the instances are that you're doing. So in that selection process, we ask you to select based upon those business requirements, depending upon maybe first I would start with storage. Depending upon storage, customers should choose from perhaps i3, our D2, D3 options, or H1. Alternatively, you can select from persistent storage using EBS. Networking, taking a look at the networking options. We have different networking requirements. We have our high networking options with N, so C5N, M5N, R5N, and I3EN instances. Memory, so depending upon the memory and your memory requirements, you can choose from additional memory. Maybe you start with an R5, I mentioned that 8-to-1 ratio, but if you need even more memory, we have X1 and our recently announced X2 and U instances. And then we have accelerators. So based upon if you need an accelerator or you think it's a great idea, maybe the P2, P3 DN for some of the graphics, and then F1 or INF1 instances. Finally, graphics or CPU performance. So do you have, based upon graphics performance, we offer GPUs in the cloud. We offer G4 DN, G4 AD, and the G5 ones. And then finally, focus on that cost. I put cost as the last vector is because once you've decided on the other vectors, we can start to help with the optimization and then begin that optimization process to help save you money as well in the cloud. Okay, so there's a good chance that multiple instances and applications can power your application and workload. That's why we have to work through that priority list that I talked about a little bit before. So the more flexible you are, the better that offering is. So I'm going to talk about what is that flexibility. Flexibility to me is not just, do I choose M? Do I choose C? It's also, where do I launch this? Do I use the US East 2, US West 1? How many AZs do I use? The more flexible you are in the fleet, for example, maybe you want to run an M5A. Can you also run M5? Could you also run an M5G? Could you select multiple AZs within the same region? All of this is flexibility. The more flexibility you have, we offer additional options to start that's when we can help with that optimization process. My final tip is to work backward from the workload for performance requirements. We talked earlier about making sure you select that correct instance option. But the key is to look at your application and determine what type of performance and what are those minimum requirements that you have. So work backward from the application. And is you're an application that needs certain CPU frequencies? Maybe you're a customer who's doing silicon design and you're testing EDA workloads. So perhaps taking a look at some of the high frequency instances, maybe the M5ZN or the pre-announcement we had for X2i EZN type thing. That may be something you need to target as opposed to looking at some of the other options. Maybe that's your first thing. Or is this an application that needs a combination of GPU and CPU? Maybe you should take a look at G4 AD or G4 DN or the G5 platform, which is even cheaper now. So, or is I/O your bottleneck? So all of this is the working backwards here. And then what do I mean by that attribute approach? Here's what I see as the attributes you would choose for. Talking about these, I've talked to you a lot about the processor, the selection processors. We have processors, I say here up to 4. I should have changed on the slide, up to 4.5 gigahertz we've now announced is our highest speed processor. And you think about it, with our new generation, the AMD processors have up to 3.6 gigahertz, the Intel processors on 3.5, and then having an offering of even up to 4.5 is pretty significant. And then the other side is the architecture base. Are you an x86 based platform? Or do you have the flexibility, maybe you're using containers, or you have other flexibility and you can start to use ARM. Or we can also alternatively try to work with you as well to move over and migrate to the ARM application. So focus on the capabilities and options that are required for your application and your workload. All right, here's a big slide talking about lots of different things. I'm going to try to narrow this down. I won't be walking through every one of these. But I want to talk briefly about the choices that we have here, because I spent a lot of time talking about them, and I think this slide offers a visual here for all of the offerings that are out there. So customers have that wide range based upon the latest CPUs and GPUs and our custom accelerators that are out there. Customers looking for that high performance compute can run training and inference on deep learning models or leverage some of our GPU work here. So we're constantly introducing new generations of these GPUs and performance-optimized CPUs, and also our compute-based platforms. So if we start here, taking a look on the left here, you can see our traditional machine learning platforms here. I've listed a combination of our existing 5th generation and 6th generation processors here. And then as we move to the right, you start to get a lot more purpose-built and a lot more specific here. So as I move to the right on the slide, you can see the inference offerings and also our training offerings as well here. So we continue at AWS to invest in innovation in the custom accelerator business here. And we power instances that are custom built for this machine learning if you're doing that machine learning, and both training and inference here. As these accelerators are designed to do one thing only, they're able to deliver the highest efficiency and lowest cost for you. So our new EC2 DL1 instances are powered by our Gaudi accelerators from Habana Labs, which is an Intel company, and they deliver a 40% better price per performance than our prior generation. So that was just introduced this past summer here on the right-hand side of my slide, along with what we offer in the Trainium space after. So here's a summary now of that attribute-based approach I've talked about. So first, do you need a specific processor type? Do you need to choose at the company you work for, are you only Intel or AMD or Graviton or ARM? Can you take advantage of our burstable performance instances? So burstable performance, that's our T family, and those are the cheapest instances that we offer in the EC2 compute family. If you have a somewhat constant level of compute with some burst that happens, the burstable instances might be worth exploring. Can you take advantage of ARM processors? I talked to you about the G3 that we just announced, and I also talked to you about the Graviton processor. Is that a possibility for you to take a look at? How much memory do you need? What is your memory to CPU ratio? You need to determine that as you take a look. I already spoke about my next item here. And then, what is the network performance requirements? So what is the EBS networking performance minimums that you have? Because we also offer a variety of the networking and EBS numbers as well. And finally, do you need accelerated compute? So are you looking for a GPU? Are you looking for an FPGA? This is the attribute-based approach that I think is the best place to get started. Let me give you a couple of workload examples before I turn it over to Chris here. This is a simple web server example. And in this example, you can see that the customer is using multiple availability zones. In this case, they're using availability zone A in the top and B in the bottom. So in this case, 2. I'd recommend, if you can, be even more flexible, potentially selecting 3. My slide is out of room for a 3rd. That's the only reason it's not here. So given the workload, given that this is general purpose compute, in this particular example, the customer here is looking at doing an M5, M5A, and M5G. That means they're cycling through all three of the processor types that we had here. This is the greatest flexibility that someone might have. Maybe you're only x86 based, and the example for you would just be M5 and M5A for the processor type here as a different performance. And in this case, the 2 AZs are mirroring each other, but a pretty simple example of how you might set up your web server. Getting a little bit more detailed oriented here, this is the an HPC example here. A little bit more complicated than the earlier example, but where you can see that machine learning and analytics data has to be fed in to our cloud-based auto-scaling. We have this, in this particular case, you're migrating data from your S3 storage and in S3 Glacier here. And you might have additional data that's coming here on the left-hand side from collaborators. All of that is being comprised in the middle here on the Amazon VPC client here. But this creates an idea of how you can move your architecture over to the cloud, complete with using storage, shared file here, and the HPC clusters that we offer. Excuse me. My final HPC workload example here is an example of a customer who is using multiple availability zones, in this case, the 3 that I had mentioned earlier. And they're also using an interesting type of fleet here. They're running through C6i XL. OD stands for on demand. And we'll talk about the pricing thing here as well briefly as we go forward. And then M5 large spot and the C5 large spot instances. So what's happening? In this particular case, the customer is taking advantage. They have a base level of performance that's required with your on-demand instances. So on-demand is for stuff that can't be really interrupted. You absolutely need that performance at one time. And then they're taking advantage of Spot. Spot, by definition, is our extra capacity. And for using a Spot instance, we offer a discount of potentially up to 90% on the cost. If you have a workload that can be interrupted, which can happen on Spot if there are additional on demand, we will come and reclaim some of our Spot instances, giving you a 2-minute warning. You get a price advantage here. So this customer recognizes they have certain workloads that require fixed performance using the on-demand, and then they're able to use Spot. TIBCO is one of our key partners at AWS, and they've integrated their product with ASG and our Spot-based practices. And now the customer is able to take advantage of a mixed pool of Spot and on-demand instances, and they can scale their grid workload on AWS. This change is really exciting for customers who are running large-scale grid workloads and use AWS services natively using a pay-as-you-go model. And then finally, I'll talk through this deep learning here example. So this is an example how a complex deep learning usage can be, but also how simple it is for deep learning to be done on AWS. So here, you have your memory to the right in the S3 bucket, and that feeds into the larger managed service, managing using our EKS, Kubernetes. Then the customer is able to use our Inferentia chip along with a GPU accelerator, G4DN in this case, along with the compute C5 workloads to finish that goal. This is all contained within the Amazon VPN. So next, Chris is going to walk you through how to discover and locate EC2 instances and talk to you about how to manage capacity and pricing. Chris? There you go.
Awesome. Thanks, Art. So Art spent a good amount of time talking about the selection process for EC2 instances. And it's something you probably recognize now is that we offer a very broad and deep platform of choice, of very workload-specific instances. So we're also investing in making it easier, right? We want this platform to be easy to use. And one of the things you want to think about is, well, you know what? If I'm going to do this manually, that probably can get kind of cumbersome. And so you might be asking, is there a tool I can use to make this process a little bit easier? I'm going to tell you about 3 of them. So the first tool we'll talk about that was launched a little over a year ago is the Amazon EC2 Discovery tool. And the whole purpose of this is really optimize the experience of the instance selection process for planned workloads. What the tool does is basically customers will input their hardware requirements. So think, how many vCPUs do I need? How much memory do I need? Do I need bare metal instances? Right? You're going to input these kinds of things. And the tool is going to return a list of instances that's going to be up to date all of the time. And that's what's really important about this, because this can become your single source of truth. So pre-reInvent, you might have said, okay, well, how many instances do we have available? And now post-reInvent or in reInvent, we mentioned we've got over 475 different instances, and we're going to have additional launches perhaps throughout the year. How do you keep things up to date, right? And this tool can be that single source of truth for you. So this tool, when we actually offer it, we do offer it, but it's offered in a couple of different ways. So the first is through the EC2 console, and I'm going to walk through what that looks like in a moment. But the second way is we actually offer programmatic access for this. Now, this is cool because now when you have programmatic access, you can actually integrate this into your workload provisioning. So what I mean is that if you have a Terraform script or a CloudFormation script, and perhaps you have certain instance types you're looking to launch for that workload, instead you can basically ping the instance or hit the instance discovery API and get an updated list of instances based on the attributes that you're looking for, right? So it'll always be up to date, which means that there's fewer changes you have to make, which means that there are fewer mistakes that you'll be tempted to make in that case. So let's talk a little bit more about what this experience is going to look like. And I'm going to show you a demo of a few slides. So if you go to the EC2 console, the first thing you're going to see is, of course, a list of options. Under instances, you'll see instance types, and this is where the tool lives. You'll see a bar at the top where you're going to put in your filtered options. We're going to talk a little bit more about what kind of things you can input there. But you'll see at the bottom, once you put in your filters, it will return an updated list of instances combined with the attributes of those instances. You have some freedom to customize that, which I'll get into in a moment. It also returns the pricing of those instances. So you can now see prices across availability zones and across regions, and you can start to make some basic comparisons. So you might see, hey, you know what, maybe some instances are cheaper if I go to, maybe US East 1 versus US East 2. Maybe I can go across and maybe pick another region. So you can start to make some comparisons there. But let's look at customizing this experience. So if we look at the top right-hand corner, you'll see a little gear. If I click that gear, it'll take me to the customization screen. And here I can see a set of preferences. On the left column, you'll see I have a page size selection. So I can customize how many entries are actually returned on the screen. And of course, certainly if you have a larger display, you might choose a larger page size because then that's less things that you have to click through and scroll through in that case. So that's the first thing you want to consider. The second thing is we can now start to customize what kind of values are returned per instance. So by default, instance type is always going to be shown. But you can start to look at maybe other things that I might care about. For example, you can show how much memory per instance. Or perhaps you might want to show both vCPUs and physical cores because for your application, the performance might change depending on how many physical cores that you have. So these are all the different things that you can start to return and show and really customize the view just depending on what you actually care about. So now we've done this, let's go back and click and start adding in attributes. So I can see for instance types, I can start to filter down and enter some things. And there's many different set filters you can use. For example, if I put current generation, it will filter by the current generation of instances, right? So you can see the latest and greatest if that's where you choose to start. If I put metal, it'll return bare metal instances. I can also, for other values, I can put in ranges. So imagine your application, perhaps you need at minimum 4 vCPUs per node, but you really don't get much performance benefit when you go past 32 per node. I can choose a range command and say between 4 and 32, and it'll return all the instances that have those attributes in between. And I can do the same thing for memory as well, too. So you have a lot of flexibility in terms of using this attribute style-based approach, and you can basically leverage that through this tool to return always an up-to-date set of instances. The second tool we're going to mention is the attribute-based instance type selection, and this is pretty new. This is actually released a little bit over a month ago. It does something similar to the instance discovery tool, but it's integrated within auto-scaling groups in EC2 Fleet. And what this allows you to do is, similarly, I can express my instance requirements as a set of attributes. So think vCPU, memory, what kind of storage do I need, those kinds of things. And it'll return a list of instances that fit that, and it'll basically input that into the auto-scaling group configuration. Now you might be asking, well, what does this really do for me? I'll tell you. So one of the things, the secret sauce to really getting a lot of capacity is instance flexibility. And there's a very public use case of Western Digital where they were able to get 1.1 million vCPUs. They leveraged spot instances to do this, and they used 16 different kinds of instances across 6 different availability zones. That means that their auto-scaling group had a list of 16 different instances. We call that the override list of the auto-scaling group. So one of the things I talk to customers about getting large amounts of capacity is finding all the instances that work for their workload, building a list, putting those in the auto-scaling group, and that takes time. But what this is doing for you is it's taking that process out. You just tell it exactly what kind of attributes you're looking for, it'll populate that list for you. In addition, similar to the instance discovery tool, this will always remain up to date. So now you're future-proofing your workload because your attributes may not change, but the instances probably will as we come out with new instance types. So ultimately what this is going to do is it's going to save you time. If I look at what kind of workloads this is ideal for, so anything that's instance flexible, Instance flexible frameworks. Think containerized applications would be an example of this, right? By definition, Docker is effectively an abstraction layer. Per task, you probably don't care about what the underlying hardware is, but what you probably do care about is maybe how many vCPUs and how much memory I have per task in that case, right? So you can afford to be very flexible across maybe instance families. You can use C4s, C5s, M4s, M5s, the R series in that case. And this makes it a lot easier to do that. Also, if you think big data-based workloads, right? If you have a Spark application, that tends to be very instance flexible. That's another way you can use this tool as well as CI/CD-based applications. Also, if you're using EC2 Spot, as Art mentioned, that's the excess capacity of EC2. Spot's a very effective way to get large amounts of capacity very economically. But as a Spot best practice, we ask for it to be a fault-tolerant workload because there's a chance it could be interrupted. Doesn't happen often. But it could happen. The other thing is that, you want to be instance flexible because the way Spot works, the way when it works with auto-scaling groups, is that, and we'll talk about that in a moment, but perhaps the exact instance that you asked for might not be available, but there's a good chance there's another instance that could work very well for that workload. If I use a hotel example, right? So let's say you call up a hotel, you say, hey, do you have room 314? And they come back and say, no, we don't have room 314. You turn around and say, okay, we don't have the capacity, right? They're sold out. You probably wouldn't do that, right? There's probably a room next door. There's probably one on the floor below. There might be one on the floor above, right? So we encourage you to think of EC2 similar to that. You want to be flexible. And then the more choices that you give it, the higher chance you have getting large amounts of capacity. And if you're using EC2 Spot, the less likely you'll be interrupted because it will intelligently choose from instances that are least likely to be interrupted, right? So the more choices, the better. And as I also mentioned, it also future-proofs your workload. So very exciting tool. It's something a lot of customers have asked for, and we encourage you to use it. And then the third is the EC2 Instance Selector. So this is an open source CLI tool. It's very similar to the Instance Discovery tool, but it's open source, right? So you get the additional flexibility that comes with that. And we have the GitHub link below. But if you Google Amazon EC2 Instance Selector, it should be able to come right up, and you should be able to find it and download it and get hands-on with it. So something else to consider as well. Okay, so you have an idea of the different tooling, and you understand the process to go through the 475 plus different instances and find the ones that work for you. Now you're thinking, okay, now how do I go about optimizing across price, capacity, and performance? And let's kind of talk about that a little bit. So one of the questions I often get are cost and performance mutually exclusive things? Right? If I'm optimizing for cost, does that mean I forego performance? Right? Is it a trade-off, cost trade-off between performance and availability? Not in the cloud. It's really a matter of understanding your pricing options, and you're going to use the right tools to manage capacity and take advantage of the guidance of these best practices. So as Art mentioned, you don't want to optimize for cost right away. You want to figure out the right instances that work for your workload, right, using the tools that we talked about. And then I'm going to layer on different purchase models that's going to cost optimize. And the purchase model you choose is really going to depend on the workload. Let's talk about that. So 3 different vectors to optimize. We can talk about pricing first, right? There's fundamentally 3 different purchase models for EC2. The first is on demand, right? You have over 400 different instance types. You pay by the second. It's very flexible. There is no commitment required. If you spin up one, you choose, hey, you know what? Maybe an M5 isn't the best. I can go ahead and turn around and spin up an R5 instead, right? So I have a lot of ways to play. That's where a lot of customers start their journey. After that, it becomes a question of, is your workload steady state or is it burstable? Or is it elastic, right? If it's a steady state workload, then we encourage you to cover that on-demand spend with a savings plan. Savings plan is a mechanism where you're basically making a 1 or a 3-year commitment, and you're getting somewhere between up to 60 and 70% off of the on-demand price. So as I said, very good for steady state workloads in that case. Savings plans are also instance flexible. So once you purchase a savings plan, you can move between different families depending on which version of savings plan you get. But if you get the compute savings plan, you can move between different families, go up in size, different sizes. So you've got a lot of flexibility. If you find that maybe one instance worked today, it's something new came out tomorrow. We've launched plenty this week, right? You have a lot of flexibility to make that change. If it's a fault-tolerant and burstable dynamic workload, we encourage you to leverage spot instances. Just because spot, there's no commitment required. It comes with a very significant discount, up to 90% off of on-demand. And so in that case, if you're thinking you're doing something like job processing, right, where you don't have it running all the time, maybe you have a workload that you're running, it's once a week, or maybe it's an annual report, that's excellent for spot in those cases. HPC workloads also very well, or containerized workloads, because that tends to change. So those are the three fundamental ways that you can leverage pricing options, and sometimes you're going to leverage more than one at once. If you imagine an e-commerce application, which is, think you're a fault-tolerant or stateless e-commerce web application, for that case, you're probably going to have a base amount of capacity you're going to have running any time of the year. That's great to cover that base with savings plan. And then as you scale up and down, you can leverage spot for those bursts and peaks, right? So if you have seasonal usage, perhaps if it's e-commerce, it's probably right now, you'd probably get a large amount of customer load. That would be awesome to cover with spot in that case. So you're going to mix spot and on-demand with that. Now, if you talk about how we optimize for capacity, one of the best tools you can use is auto-scaling groups, right? Because auto-scaling groups, it's fleet management. If you lose an instance where an instance is just naturally, it's unhealthy for whatever reason, or if there's a spot interruption, it will automatically replace that instance with another healthy one. And if it's a spot instance, it'll actually be intelligent enough to find another instance that's the least likely to be interrupted based on real-time capacity information and some historical information that the auto-scaling group has behind the scenes. So it's an effective way to basically maintain capacity. Auto-scaling groups also support multiple purchase options and multiple instance types. So I can have the same auto-scaling group leverage multiple instance types. Art talked about that in a previous slide, but I can also mix on-demand and spot with the same auto-scaling group and cover that e-commerce example I mentioned before. The other thing that auto-scaling group does really well is scaling, right? So for dynamic workloads, I have scaling policies that I can set up for it. And effectively what I'm talking about is I can tell the auto-scaling group, look for a certain amount of CPU utilization. And when I see average CPU utilization go above 80%, I want you to add more instances to my fleet because that means I need it to be more performant. I need more compute capacity. And I can also have another rule set up to say when it goes below 50%, I want you to start, if things are underutilized, I want you to start taking things away. And that last part is very important because there is no server that is cheaper than no server, right? So one of the first things you want to do is you want to make sure that if you have an automated process to turn off underutilized or unutilized servers. So that's a very important part of capacity management as well as cost optimization. That's why we talk about auto-scaling groups so fondly. The last thing we put here is performance optimization. So we've talked about instance flexibility and why that's so important, and we've got these different purchasing models that allows you to be instance flexible. Don't get so spun around the axle of trying to make the right decision right away. The big difference between cloud computing, or one of the big differences between cloud computing and purchasing on-premise is that you don't have to buy a server and then hold on to it for the lifetime of the server. You can easily make a choice and find out maybe there is something else that's more performant, that's more right size for your workload, and in the next second you can go ahead and change servers. So you're not really committing to anything in this case. And that's something that you want to keep in mind, right? It's really a two-way door in many cases when it comes to server choice for performance. But we do have tools to help you with that, and a powerful one is the Compute Optimizer. So this is something that was launched, I think it was a little over a year ago. And what the Compute Optimizer does is it looks at your historical utilization of your CloudWatch across EC2 instances, EBS volumes, and Lambda. And it will make up to 3 recommendations per resource. And it makes those recommendations based on We have models trained over millions of workloads. And through that, it's going to look at things and see, okay, are there any underutilized instances? Perhaps you can use a smaller instance. Perhaps you find that, you know what, by upgrading from a C4 to a C5, you could save 30%. Or what it'll do is identify performance bottlenecks. So perhaps you have an M5 and it realizes, you know what, you're a little memory constrained, so you'd probably be better off with an R5, and it'll start to make those recommendations too. So it's something else that you want to consider, is leveraging the Compute Optimizer. The good thing is that it's a free tool. So it automatically will go over 2 weeks of historical data. But let's say that you have maybe monthly or quarterly analysis that you want it to do. There is a paid feature that will go back up to 90 days and look at that 90-day utilization. And it will use that to actually build its recommendations. The paid version of this, it's basically called Enhanced Infrastructure Metrics. And it costs a little over 3 cents for every 100 resource hours. So it's definitely something that's an option as well. So what are our key takeaways? The first is we've got a lot of different instances, right? And they're for a variety of different use cases. Don't get taken back by all the choice. It's there for a reason. But just familiarize yourself with the basic categories and begin to take an attribute style approach as you make those selections. So once again, how many vCPUs do I need? Is it an HPC application? I have a lot of internode bandwidth and communication, right? And I need to start looking at instances that have enhanced networking in that case. Then I want to leverage instance type selection tools like the instance discovery tool and attribute-based instance selection to help refine that and automate that process. And then after I integrate those things, I want to optimize across price, capacity, and performance. For pricing, you're probably going to start with on-demand, but look at where you can leverage savings plan, right? If it's a steady state workload, look at savings plan. If it's a fault tolerant or a stateless workload, Spot is an awesome choice for that. We have a lot of customers that are leveraging large amounts of Spot to drastically either bring down the price, we set up to 90%, or imagine for the same price, you can get 10 times the amount of compute. We have several customers that are basically leveraging this way. One example would be like Fred Hutch, and they're leveraging Spot to do cancer research and getting much more compute, about 10 times the amount of compute. They can reduce the time to insights. So that's something to think about too. For capacity management, leverage auto scaling groups. It scales out, it scales in, it does fleet management. It's an awesome Swiss Army knife that does a lot of things very well. Or EC2 Fleet if you're more developer minded. And then the last thing is Compute Optimizer for performance is a great tool, and we're constantly updating it. So that's something you want to leverage as well. So with that being said, thank you very much. We hope you learned a lot here. We're going to take a little bit of time at the end to answer questions at the bottom. But one thing we would love you to do is also fill out the session survey. These are taken very seriously. So if you could take a moment, if not now, maybe when you get back to the hotel room, let us know how we did. Thanks.